Hi everybody, and welcome to our webinar for 3D scanning and 3D probing. My name is Christian Gerbic. I'm a territory sales manager here at EMS, and with me is Dan McConnell.
Hi everyone.
Dan is one of EMS's application engineers, and he's worked in the 3D space for over 10 years now. Dan and I are often on the road together meeting with clients, so he works on a number of service projects as well involving scanning, probing, modeling, and inspection, all of which we're going to talk about today. So we've got a couple other folks helping us from behind the scenes today, Mark Kemper and Claire Wilson as well. So the goal of today's event is to provide everybody a baseline understanding of what 3D scanning and 3D probing entail and when it makes sense to employ one or the other. And we're going to address the benefits of each as well as note some limitations as well. So what you can expect over the next several minutes is, first, I'm going to provide a little bit of background about EMS and what we do. Then we'll get into the crux of the event. Dan's going to demonstrate the scanner and probe using the truck grill that we have set up here. Then we're going to address some questions that folks have submitted through the chat. And then finally, I'll show you a couple places where you can find additional information about 3D scanning and probing. The event is designed to go about 25, 30 minutes. Everybody's phone is muted, but if you have questions, feel free to submit those using the chat function. So first, a little bit about EMS. We've been around since 2001, and we're a provider of 3D scanning and precision measurement solutions that improve the speed and efficiency of design and quality processes. We have two offices. Tampa is our headquarters, and we have personnel in the Detroit area as well. We have a very diverse client base, and we've worked on projects all over North America. Naturally, our Detroit colleagues, they do a lot of work within the industrial and automotive space. And our Florida office, we do a lot of work within aerospace, marine, power gen, and we've also developed solutions for some of the automotive OEMs in the southern states as well. So EMS, we typically work with our clients two different ways: product sales and professional services. First, we're an authorized distributor for a number of equipment and technology companies, so we can assess clients' challenges and package hardware, software, and training that help clients overcome those challenges in-house. We also provide outsourced services for 3D scanning, inspection, and modeling. Over the years, we've completed over 20,000 projects and scanned everything from tiny implantable medical devices all the way up to gigantic C-5 Galaxy aircraft. So a lot of the work that EMS does is solving challenges related to reverse engineering and inspection. Now, when we talk about reverse engineering, it's typically within the context that you have a physical object but require digital data. And occasionally simple outputs like point cloud or polygons will suffice, but most of the time the client's going to need usable CAD, IGES, Parasolid, or STEP files. In EMS, we also do a ton of work within the metrology space, where scan data for an as-built item is compared to intended design and deviations are identified. So the boring stuff is now over. We're going to get into the good stuff here. Dan's going to demonstrate several benefits of scanning and probe using the truck grill we have set up. So Dan, please take it away.
Awesome. Thank you, Christian. Hi, everyone. My name is Dan McConnell. I'm an application engineer here at EMS. So my job here is just to go through the scanner and probing system with you. I'll be demonstrating those, and as we go through each one, we'll talk a little bit of the advantages of each. First, we'll start off with the 3D scanner, and then afterwards we'll go to the probing. So to get started, I already have my session ready to go. So all I have to do is pick up the scanner, pull the trigger, and start scanning.
So while Dan's going to town on that grill, I'm going to point out several advantages to 3D scanning. And the first, maybe you've picked up on it already, is that 3D scanning, it's great for capturing a lot of data very quickly. The second reason we like 3D scanning is that it's very easy. Anybody can do it. Thirdly, it's a non-contact process, which is advantageous from time to time. And lastly, it's ideal for capturing complex and organic surfaces. You'll likely notice right out of the gate just how much data Dan has captured Dan, tell our audience what you're up to right now, how this works.
Sure. Kind of what you had said before, 3D scanning, that's the first big advantage. It just captures a lot of data very quickly. A lot of the scanners that we use here at EMS will capture upwards of well over 1 million points per second. So in this short amount of time, I've already captured well over just millions of points. I can use that data to do multiple things, right? Now compared to actual probing, it's just not feasible to do the same type of a data acquisition where you'd have to physically go and just grab millions of points. The second big advantage to 3D scanning is how easy it is. I literally just pick it up, pull the trigger, and start scanning. It's very, very, very easy, user-friendly, and we like to say that if you can pick up a can of spray paint and use a can of spray paint, you can pick up a 3D scanner and use a 3D scanner.
So Dan, he really hit the head of the nail on that one. We call 3D scanning digital spray painting. You just point it, aim, and pull the trigger. So the 3D scanning operating software is going to make it real easy for Dan by showing him what he scanned in real time, so he knows what he's already scanned and what he's maybe missed.
Yeah, and as you see, while I'm scanning, I'm really keeping a conscious effort to how close or how far away I am when scanning. And the key part of that is not really the technique of scanning, it's more so to realize that I'm not touching the part. 3D scanning is just a non-touch system where I can gather the data of my surface, opposed to probing where you have to actually come in contact. The big benefit there is there's no risk of moving the part or causing deformation in the part that would end up skewing your data results.
So another time we employ 3D scanning is to capture complex inorganic surfaces.
So this chuck grill is probably a little difficult to see possibly from the camera angle, but this truck grill is a very non-prismatic shape. I mean, there's not a lot of flat surfaces or just basic type of surfaces like cylinders, spheres, things like that. It's actually curved in multiple directions. It's curved front to back, side to side, and that's where scanning really shines, where it can grab something that you can't just take a pair of calipers to and measure something. It's something that's organic or just very, like I said, complex geometry. One big thing you can do with that, which I'll pull up here right on the screen, would be color maps. So this is a color map of this grill. And how you obtain that is actually taking the 3D scan data we capture here and we overlay that with the CAD data. And you overlay that depending on maybe you have datums or maybe it's just best fit. And by doing that, we can just at a glance see a go, no-go type of qualification when we look at our actual scan data of our physical part. So with this, it could be a go, no-go, that's a good. Or maybe I look at this and I look at the bottom of this grill and I see that it's orange. And I'm like, well, why is that orange? And then from this color map, I can go maybe and isolate that area and just put surface callouts all across that area to kind of see exactly where it's going in or out of tolerance and determine if that's a manufacturing problem or maybe it's even a tooling problem where the tool is starting to wear out and needs to be either refurbished or replaced.
So another area where 3D scanning is becoming more and more prevalent is automated inspection within manufacturing. This is because scanners can capture a lot of data over a very large area relatively quickly. Naturally, this makes QA processes more streamlined and creates digital record. Companies can use this data for developing trending models and even predict tooling fatigue or failures. So, coming back and summarizing the benefits that we've discussed regarding 3D scanning, number one, captures data very quickly. 2, it's very simple, anybody can do it. 3, it's a non-contact process. 4, it's great for capturing complex and organic surfaces. And lastly, it can be automated. So now we're going to change gears and focus on probing. Now probing on the outset might seem slower than scanning, but in fact, probing provides a number of advantages for the type of work that we perform. For starters, inspection functions, they can be pre-programmed and sequenced for the end user. And secondly, probing is just a better, faster means for checking basic features on an object. Third, Probing will capture tricky features like small holes and obstructed surfaces and cavities that line of sight scanners just can't get. And fourth, sometimes it's just a standard set by the company that's performing the inspection. So Dan, he's going to use the handy probe right now, capture some data on the back side of that grill.
Sure. So what I'm going to end up doing, I'm going to show you more of a example of automated sequencing with the probe partnered with an inspection software. So the inspection software we're using here, as you can see on this screen, is Polyworks. And what I'm going to do is just kind of walk through what it's doing. So the software itself is going to walk me through what exactly it wants me to find. So right now, I want to measure 2 slots and then measure in between the center points of those 2 slots. So it's going to ask me here, it's going to say, please grab arc number 1, which I'll do. I'm just going to go ahead and put the tip on that arc and grab 3 points, accept that arc. Then I'll go in and grab 3 more points, accept that arc, and then it'll move to slot number 2. 1, 2, 3. And we'll do 1, 2, 3. And we'll accept that arc. So it's going to go ahead and auto-generate 2 slots, and then, as you can see, it's grabbed a measurement. So right now it has a measurement of approximately 397 millimeters from center point to center point. Now automation is just great for repeatability. So I can say if I have a dozen of these grills that I need to inspect in a given day or whatever time frame it might be, I can take my first grill, set it up on my fixture it down, grab my alignment, and just follow the sequence that the software tells me. Just grabbing every single surface or every single basic geometry, and then it'll spit out a report, and then I can save that report, add a next part, remove this grill, bring in a second grill, and fixture that down, and just repeat the process over and over again. Like I said, very repeatable and very user-friendly once it is set up.
So the backside of the grill can certainly be scanned, but in the real world, it's going to make more sense to use a probe because the OEM and the supplier, they want to ensure the part properly attaches to the truck. The manufacturer, like Dan said, they're installing dozens, maybe hundreds of grills per day, and they want to ensure the attachment points are going to be in the right spot. So quality departments, they can set up an automated inspection program using a software like Polyworks to guide an end user through the inspection process, just like Dan demonstrated. So Dan, let's talk a little bit about using probing for checking very simple geometries.
Sure. So probing for simple geometries is really it's a nice way or an advantage of probing. When you just want to grab something very basic, you don't necessarily need to scan a cylindrical area, or for instance, the area that I ended up probing just now with the sequencing. So if I was just wanting to grab that one basic entity or that one measurement, probably not going to put up a whole sequencing for that just because it's just one area. Sequencing is more for a full inspection or even partial inspection when you're grabbing just multiple geometries. Now, usually we need the CAD for. Now, with just basic quick measurements, you don't even need the CAD. All I had to do was just kind of grab my 2 geometries and then measure in between. So it's a great way to figure out, whether or not a plane might be parallel to another plane or perpendicular, or how round a cylinder is. You're just grabbing a handful of points to pull out a geometry or a measurement, and then comparing that just with what you know is nominal.
So another area where probing is helpful is overcoming line of sight issues. Think of an engine block. The bulk of the exterior can be 3D scanned, but critical features like center lines, like bore center lines and water jacket locations are machined several inches into the casting, and scanners are just going to struggle to capture this data. So probing with varying lengths or angles of Renishaw attachments are often employed. In the images you can see here, there is just no way to scan them because, frankly, they can't be seen. So in the same vein, probing is a better option for capturing geometries like holes in stamped sheet metal. Dan's going to show us an example of that right now.
Sure. So what I have in my hand here is a piece of stamped sheet metal that's been formed. Now, where you would use 3D with the probe instead of 3D scanning for sheet metal is because when you're trying to do a scanners have difficult time finding that edge of the sheet metal because it's how thin a sheet metal is. So, if I were to scan this, I would get the actual facade fairly well, but I really couldn't get a great gauge for how deep something was, or just really where the edge was precisely, because there might be some noise or what have you. So, what I would do is I'd take the probe, I'd take my part, and I would fixture it down somehow, and I would take my probe tip and say I wanted the location of one of these holes. I go in and I grab my 3 to 4 points to just grab that hole, and I'd find the position. Now, to do that, I could do that to really find the maybe diameter of the hole, but most likely I already know the size of that hole. I already know it needs to be 10 millimeters or 8 millimeters or a 1/4 inch, and I just need to know where exactly to put that hole, just the location, so then it can be drilled out.
So probing, it's often utilized within sheet metal applications. It's very common to see probes utilized in aerospace, MRO, and automotive applications. Probing, it's also agnostic to surface types, and sometimes different surface types are going to present challenges to 3D scanning.
Yeah, and some of the surface types are something that's overly shiny, or chrome, or dark. The big one is clear, like the part I'm holding here. And when you're dealing with scanning, you're dealing with light, you're dealing with lasers or structured light, and light just passes through clear objects. So with probing, since it's all about contact, as long as the surface can be touched with the probe without deforming or messing up the surface of the part, you are able to touch that probe no matter what type of surface it is and grab that geometry. So if I were to grab this flat plane up front, I could grab 4 points, grab a plane, and then I could figure out how perpendicular it is to this bottom surface, or I could just kind of grab some location points on this curved area.
So the last thing we're going to mention today about probing is that it's often performed for no better reason than it's just prescribed by the company.
That's right. It could be just prescribed by the company. Maybe back when a part was created or just went into production, it was first certified with probing. And even if maybe scanning makes more sense or might be quicker, you're constrained to how the part was originally certified, and that's really common in maybe aerospace, power gen, and other industrial companies or industrial avenues, basically.
So building on what Dan was saying there is, sometimes it's mandated because perhaps that part was initially qualified using a CMM, and maybe that was long before 3D scanning came into the mainstream. So, that wraps up probing, and I'm just going to bring together the advantages that we discussed here for probing. And one, it's a programmable process that allows end users to follow a sequenced step of instructions for performing inspection work. And secondly, it's just a better, faster means for checking basic features on a part. Thirdly, probing is going to capture features like deep holes or transparent objects. And lastly, sometimes it's just prescribed by the designer. So that opens up our webinar for some of the questions, and Dan and I will do our best to answer a few here that have been coming through the chat over the last few minutes. And Dan and Claire, or Mark or Claire, are going through those right now, and they've got some here up on the screen. Here's a good one. Somebody asked, well, they kind of point out and then they ask. You said that you need to probe transparent objects in lieu of scanning. Why can't you just dust the parts? No, that's perfect. That's a great question. Thank you. Dan, you do a lot of this work. I'll kind of let you handle that one if you'd like.
Sure. So for some people who don't know, dusting is a technique we'll utilize. It usually comes in the form of an aerosol can. It's either acetone or alcohol based, where you spray it onto a part, and it also has a powder mixed in. The alcohol or acetone rapidly evaporates, leaving a fine powder, we use that on shiny objects or clear objects, just so we can get a really nice scanned surface in our data. Now, some areas where you may not want to dust are items like sensitive electronics or surfaces that could potentially damage either by the powder or even the alcohol or acetone that's used in the aerosol.
So we had that project the other week where we were doing an inspection job on a piece of some machined metal parts, and the accuracy requirement on that was so high that we could not dust the part because it would skew the results. So that's another instance where probing might come into play. So another question here is, somebody asked, so they asked, we've talked about scanning and we've talked about probing, and they sound like they're maybe mutually exclusive. Why can't we use them together? And I'll take that one. So they're used very often together. We had a project some time back that involved 3D scanning an aircraft, a very large aircraft. So think of an aircraft. It's built of a lot of sheet aluminum, very thin, very lightweight parts. So to model that aircraft, the very large swaths that we would do, we would pick up with a scanner like the Metroscan that we use today, maybe a medium range or a long range surfacer to capture just that bulk data. And then depending on the project, and this comes up very often, maybe there are areas of that aircraft that we have to pay very particular attention to because that's the area that they might be doing an upgrade, a modification, a retrofit, and we need to capture very detailed components like cutouts for the cables or the hydraulic wires or just the weight-saving cutouts that they do on an aircraft. So that's where we're going to get in with a probe and hit that and get very detailed data to put into our solid model.
Yeah, and to kind of build on that, another way that the scanner and the probe can be used together would be, using the probe to probe maybe a fixture or a jig to get a coordinate system established, and then having a part placed in that fixture, and then when you're scanning, you're scanning the part in that orientation.
Mm-hmm. So there's a few other questions over there, but for the sake of time, we'll feed back to those individuals after the webinar here in the coming days. So we're going to move on to just kind of wrapping things up here for everybody. And really, we've hit everybody with a lot of info. Let's just kind of take a minute, boil down what Dan's shown us here. And really, there isn't a right or a wrong tool. It's more so, what's the best tool for the job? Scanning's great for capturing a lot of surface data and quickly capturing surfaces with very complex organic surfaces. And scanning doesn't require touching a part, which is just not always possible. So probing, the probe can capture basic geometries and simple features with a very high degree of accuracy. The probe's going to be great for basic dimensional checks, and surface types really never going to play a factor. Probing is also a better option for checking thin-walled objects, like in sheet metal. As we mentioned, probing can also overcome the line of sight issues that can come up in scanning. You also see probing mandated in some contracts just because the CMM inspection may have been how the part was originally qualified when it was designed. Lastly, probing, as we saw, is a very simple process for an organization to employ. Probing can be paired with inspection software like Polyworks that's going to guide users through article inspection and providing the end user an instant go, no-go result. So really that brings us to the conclusion of today's event. If you have webinar topics that you'd like us to address in the future, let us know in the chat or email us at info@ems3d.com. Finally, I'm going to plug EMS's YouTube channel. We post new and original content almost every week. This channel provides a ton of information about the latest state-of-the-art metrology equipment, technology, as well as real-world application examples. So with that, Dan, I think this is a wrap. Thank you very much for your time, and we hope to see you on future webinars.